Okay, so this is the first page that is in your guys' notes here. And today we're gonna how to recognize a linear equation and how can you draw its graph. My partner will be you today because we'll be working with a partner. It says use the equation 1/2 x plus 1 to complete the table. Choose any two x values and then find the y values. This is going back to what we did the other day. You are gonna have to choose values for x. When we set ours up the other day in our notes, we set up a chart that looked like this. I had an x value. We put our function here, what y equals, and then we got out a y, and then remember, we roll our x and our y as ordered pairs. And we chose values for x here, or I gave them to you. From here on out, you're gonna be asked to choose the values of x. And we need to be careful on how we choose these. I wanna choose values for x, so when I take that x and I substitute it in right here, it makes it easy to get my y. When you see this fraction right here in front of it, multiplying by a half is like dividing by 2. Multiplying by a half is like dividing by 2. So wouldn't it be nice if values of x that I chose were evenly divisible by 2? Because if I choose the value, let's say of 5 there, 1/2 of 5, well that's 2.5 or 5 halves. 5 halves plus 1 be 5 plus a half. It'd give me 3.5, and I can certainly do it, but it would be easier if these were integer numbers. One value that's always gonna be nice and easy to choose is when x is 0. When x is 0. Because if I put in x is 0, that means I have y is equal to 1/2 times 0 plus 1. Well, 1/2 of 0, or 0 times anything, is just 0. So you're left with a y of 1, meaning you have the ordered pair 0, 1. The point 0, 1 is a solution to that equation. It is a point that lies on the line. I can write 1 right there. What's another way to do it? Well, I'm going to choose another point. I'm going to say, how about if I choose the point 2? Why would I choose 2? Because 2 is divisible by 2, and I have 1/2 of 2. So this is y is equal to 1/2 of 2 plus 1. Well, what's 1/2 of 2? That gives me 1. Half of 2 is 1, so I have 1 plus 1, which gives me 2. I now have the ordered pair 2, 2, which is part of that line. I'm going to extend this box out a little bit. Hopefully you can see, if I get this third point, these numbers, when they have a pattern, a common difference, the number between them is the same, this will hold a pattern as well. So as you can see, the next even number I come to, if I go 0, 2, 4 is divisible by 2, and I notice my x's are increasing by 2, which means my y's are going to increase by the same amount. I hope you could predict that because these are going up by the same amount, this would go up by the same amount. To get from 1 to 2, I add 1, so I'd add 1 to 2, which makes that 3. I'm certainly going to check that though. If I chose 4, I would have y equals 1/2 of 4 plus 1. Well, half of 4 is 2, 2 plus 1 is 3, and I get this ordered pair of 4, 3. That's just part 1, part A. It says write the two ordered pairs given in there. Those are solutions. These are points that lie on the line. So I have right now these ordered pairs. I have the ordered pair 0, 1, I have the ordered pair 2, 2. I chose another one that's 4, 3. Letter C here. Plot the 2 points. We are actually going to plot 3 of them. Draw a line exactly through the 2 points. We are going to do 3. I have the ordered pair 0, 1, starting at the origin. I don't move left or right because it's 0, and I'm up 1. Remember, the x-coordinate of any point that lies on the y-axis is going to be 0. Anytime I see this 0 first, I know that point is going to lie somewhere here. Why? Because I'm not moving left or right. It's 0. First number tells me how far to move on the x-axis. I'm not moving, I'm just going up 1. Second one is the ordered pair 2, 2. To the right 2, up 2. That's looking good so far. These are linear equations that should be making a line. 4, 3, and it's right there. Now back in our notes, we chose values of x that were positive and negative because it gave us a good idea of what this line did. I certainly can only need 2 points to make a line, but this third one is confirming that I'm doing something right here because it's falling in line with it. When I connect them, it's going to make a perfectly straight line. This point didn't turn out down here, and I got some sort of curve. It's in a line. Wouldn't it be nice if I had something that's back here? If I chose, let's say, -2 and -4, just to give me some other points, it doesn't tell us to do this, but we're going to check off letter D as we go. If x is -2, 1/2 times -2 plus 1, well, half of -2 is -1. -1 plus 1 gives me 0. I have the ordered pair -2, 0 as well, and look at that. It's fallen right in line. I can see right here, I don't even have to do it. This is following this pattern. If I'm at 4, -4, you're going to be right there. And that's falling in line. I'm going to plug it in just to show you. 1/2 of -4 plus 1. Well, half of -4 is -2. -2 plus 1 gives me a -1. I have the ordered pair -2, +1. I'm sorry, not -2. -4, -1. To the left 4, down 1. And look at that line. I'm going to take care now. I'm going to take my straight edge, a ruler, the side of your calculator, a notebook, anything that's going to allow me to make a nice straight line. I'm going to put arrows on the end of my line, and I have this linear equation. It makes a line. The graph of y equals 1/2 x plus 1 is a line, and more specifically, it is this line. Every point that lies on this line is what we call a solution to the equation. All of these points, even if I add -4, -1, this is what we did for 2 days before. If you plug these back in, you get a true statement. Let's say I have an x of 0 and a y of 1. That would mean 1, going back to this equation here, 1 is equal to, actually I'll write that out, and I'll write it out on this piece of paper right here. Y is equal to 1/2 x plus 1. Well, if I have the ordered pair 0, 1, you have an x, you have a y. Substitute them in. This goes in for x, this goes in for y. 1 is equal to 1/2 times 0 plus 1. That would go away. 1 equal 1. It checks, it tells me it's a solution, and I know the ordered pair 0, 1 lies on that line. I could check any one of these points, and you're still going to get a true statement. Plug in 2. Half of 2 is 1. 1 plus 1 indeed gives me a y of 2. These are all solutions. They lie on the line. Letter E here, or actually letter D, we found a different point that lies on the line. We actually found 1, 2, 3 different points that lie on the line. Letter E, do you think it's true that any point on the line is a solution? Explain. That is what we just explained. Any point that lies on the line is going to give me a true statement when I plug it in. Is going to give me a true statement. I can see right here, this point should be 6, 4 that lies on the line. To the right 6, up 4. I could certainly test the ordered pair 6, 4 to see if it's a solution. This is your x, this is your y. 4 would equal 1/2 of my x, which is 6 plus 1. 4 is equal to, well, half of 6 is 3 plus 1. 4 equals 4. It checks. 6, 4 lies on that line. And we know that because we can plug it in and get a true statement. Letter F, choose 5 additional x values for the table. Choose positive and negative values. Does each point lie on the line? We did -4, we did -2 and -4. What if I did some other negative numbers? What if I did -8, -6? What if I said 0? Or actually, let's go. I can just fill these in because we've already done it. I chose x's of -2, or -4, -2, 0, and 2, and 4. That's exactly what I chose right there. I know they're in a different order, but that's okay. And we plugged those in, and we got 3. And then when I plugged in, when I plugged in -4, I got -1. When I plugged in -2, I got 0. When I plugged in 0, I got 1. And you can see, these are all going up by 2s. This is going to hold the same pattern. I am increasing by 1s, which make this 2 and this 3. And those are exactly the ordered pairs that I got right there. Do you think it's true that any solution is a point on the line? It absolutely is, and that's what we did. I could choose any value here. Plug in my x, it's going to tell me a y, and that point lies on the line. Why do you think ax plus b is called a linear equation? I will tell you it's because when we graph it, it makes a line. That is going to take us what we are going to do on this sheet, and this is going to be your homework. We'll look at a couple of these together. I'm going to look at number 1. What type of graph represents the solutions of the equation? Well, hopefully you're recognizing right now. When my x and my y are both to the first power. Remember, 2 is really 2 to the first power. I take 2 times 1. X to the first power is just x, because it's x times itself 1 time. Y is really to the first power. When there's no exponent, it's to the first power. When my x and my y are both to the first power, this is where it becomes a linear equation. It's a graph, it makes a line. If I graph it, it's a line. Which one of these doesn't belong with the other 3? Explain your reasoning. I can see right here, that is different. That x is to the second power. It doesn't belong in here. It's not linear. This actually makes a graph that looks like this. It makes a U shape. Something with an x squared is what we call a quadratic, and it makes a parabola. All these x's and y's are to the first power. If I graphed each one of these separately, they would all make lines. This one would not. And I can identify that because my x and my y are both to the first power. Let's look at number 3. Copy and complete the table. Plot 2 solution points and draw a line exactly through the 2 points. Find a different solution to the point on the line. Well, let's take a look at it. I can do this by making an XY table, or I can make this out here for my 3rd point. Now here my x's are 3. Don't make the mistake of saying that I want something divisible by 3. Remember, this is 3 times x. So it really doesn't matter if I choose numbers that are multiplied by 3. Anything's going to be multiplied by 3. What I want to choose, though, are points that are going up by the same amount, either by 1s, by 2s, by 3s. Something so it's going to give me a pattern down here. What would be easy ones to choose? Well, I could choose 0. That's really easy. I could choose 1. I could choose 2. Plug it in. You can make an XY table like we did in our notes. There's my x, 0, 1, and 2. You've got your function of y equals 3x minus 1. You're going to get out a y, and then you are going to have an xy ordered pairs. And that's what we're making right here, is ordered pairs. Y then is equal to 3 times 0 minus 1. 3 times 0 is 0, so it leaves me of a y of negative 1. 0, negative 1 is my ordered pair. If I plug in 1, y is equal to 3 times 1 minus 1. 3 times 1 is 3. 3 minus 1 is 2. You have the ordered pair, 1, 2. Y is equal to 3 times 2 minus 1. 3 times 2 is 6, minus 1 is 5. I have the ordered pair 2, 5. And you can see this is increasing by 3. So if I went to 3 right here, this would be 8. I can certainly plug that in and test it. 3 times 3 is 9, minus 1 indeed gives me 8. I found my pattern. I now have 4 points. The problem only asked me for 3, but I could keep going. 0, negative 1, 1, 2, and then I had 2, 5. Here's where we construct our graphs. And if you don't have graph paper, that's okay. You can just make it on a plain sheet of paper. But you are going to want to have your y, and you are going to want to have your x in this coordinate plane. I label it. There's my x-axis. There's my y-axis. I am not going to need to label anything else here. I'm going to go by ones, and I'm going to plot these points. I'm going to plot all of these, just this extra point here. I have 0, negative 1, 1, 2, to the right 1, up 2, 2, 5, to the right 2, up 5, 1, 2, 3, 4, 5. Look at that. It's making a nice line. 3, 8. Well, look at these points. Each point, I'm going up 3 and over 1, up 3 and over 1, up 3 and over 1 is that point right there. And you can see that this point is 3 on the x and 1, 2, 3, 4, 5, 6, 7, 8 on the y. This is my line. I could certainly choose negative 1, and that's going to give me, again, down 3, 1, 2, 3, over 1. These are all in a line. They have the same rate of change. This is the ordered pair negative 1, 1, 2, 3, 4, negative 4. How do I know that point lies on a line? Well, I could simply plug it in right here. Y is equal to negative 3x minus 1. Does negative 4 equal negative 3 times, or I'm sorry, it's not a negative 3. I was going to say that's not going to come out. got to write my function right. It's 3x minus 1, so I have 3 times negative 1, subtract 1. Negative 4 is equal to 3 times negative 1 is negative 3, subtract 1. What's negative 3 minus 1? Negative 4. Negative 4 equals negative 4. That checks, and I know it lies on the line. I certainly didn't have to prove that. I knew that it was going to come out that way because it is following the same pattern. And there's my line. We're going to look at number 4. Going to do it the exact same way. I'm going to choose, make this a little easier. I'm going to choose 3 values now. X's that are going to be divisible by 3. I'm going to choose a negative 3. I'm going to choose a 0. And I'm going to choose a 3. Why did I choose those numbers? I want some negative values of x. 0 is always easy to plug in. And why did I use positive 3? Because it's divisible by 3. These are increasing by 3, which means my y's are going to increase at the same rate as well. I just got to find out what that rate is. You can make a table like this, or you can simply plug them in now. You have y is going to be equal to 1/3 times negative 3 plus 2. Well, negative 3 divided by 3 is negative 1 plus 2. That gives me a y is equal to a negative 1 plus 2, or 1. If you plug in 0, that will go away. Because 1/3 of 0 is 0, you're left with 2. You can see that your y's now are increasing by 1, which is going to make this 3. And I can certainly check it. Y would equal 1/3 of 3 plus 2. That would give me 3 divided by 3 is 1 plus 2, and it certainly gives me a y of 3. I've got ordered pairs now. I have the ordered pair negative 3, 1. You have the ordered pair of 0 and 2. And you have the ordered pair of this one right here that we did, 3, 3. You got to make a little coordinate plane, and yes, it's labor intensive, but it's really easy to do. I'm going to make my y-axis. I am going to make my x-axis. There's my coordinate plane. I'm going to put some arrows there to make it nice and neat. There's my x, there's my y. I need to plot those 3 points. They should be making a line. I have the ordered pair negative 3, 1. Remember, that's x, that's y. Here's my origin, 0, 0. To the left 3, 1, 2, 3. Up, 1. 0, 2. Right there, those are nice in line. I'd expect that other one to be over here in 3, 3. 1, 2, 3, 1, 2, 3. Look at that. Beautiful. I've got 3 points. And there's my line. That's 3. That's 4. Look at that. I've done half of your homework for you. You guys are going to continue on and do 5, 6, 7, 8, 9, and 10. These right here, these are at the end of your 4.1 notes, the notes you took the other day, or the notes that are online. Those are graphs of y equals and x equals. Please check the end of your notes. We went over that. It's right here. It's these two. It's in the section before. Watch the lecture on that to see how to graph those if you didn't get it before. That is your job. Join me for a Google Meet tomorrow, and we can start going over these.